In this lecture, we are going to be considering the topic X-rays, Part 1. And today we are going to be looking at definition of X-rays and the instrument used in producing X-rays. And we also go ahead to consider the Duane Hunt Law, the mathematical expression, and how to solve problems on X-ray. Let's get started. What are X-rays? X-rays are electromagnetic waves produced when fast-moving electrons or energetic particles strike a suitable target. They are of the order of 1 angstrom or 0.01 nanometer. What apparatus is used to produce X-ray? We can use the Coolidge tube or we can use the Crookes tube. Duane Hunt Law. Look at the spelling. D-U-A-N-E, Duane, pronounced as Duane, then Hunt, and then Law. The Duane Hunt Law gives the shortest X-ray wavelength emitted when electrons incident on the target are associated through a potential difference, which is given by the wavelength lambda equals to hc all over electron volt eV. So you will see the Duane Hunt law gives the shortest wavelength. So we have the minimum wavelength as written as wavelength lambda. Okay, so this expression is equal to hc over eV. I'll call it energy E. H is a Planck constant, is a constant. C is a constant speed of light. Electron, this is a constant as well. If I substitute this, all I need is the value of V to get the wavelength as well. So when this is substituted, we arrive at this. Alright, so let's move to the next step. The expression can be summarized as E equals to EV equals to HF equals to HC over lambda. They all mean the same thing. These are expressions for energy. I can say E equals to EV. I can as well say E equals to HF. I can as well say E equals to HC over lambda. I can as well say EV equals to HF. I can also say EV equals to HC over lambda. So all you need is just to memorize these expressions, and anytime the equation is given, we can apply them depending on the quantities given in the expression or in the equation. Okay, so let's continue. Let's consider this example. This example says the minimum wavelength of X-ray emitted from an X-ray tube operating at a voltage of 10,000 volts is equal to, these are the options, 1 angstrom, 2 angstrom, 3 angstrom, 4 angstrom. So here we are asked to find the minimum wavelength, and then we are only given the value in V. Okay, so before I continue, I would like you to try this expression even before I move to the next page. This is a constant, 1.6 times 10 to the power minus 19. This is a constant. This is the speed of light, a constant. So when you substitute the value of V, you will get the wavelength. But let's see how it goes. Okay, so if we write this expression, we substitute the value C for the speed of light, H for Planck constant, which is 6.6 times 10 to the power minus 34. The speed of light, c, is 3 times 10 to the power 8. And the value for the charge, e, small e, 1.6 times 10 to the power minus 19. And the value for the potential difference is given in the equation 10 to the power 4 in index form, that's 10,000. When we substitute and simplify it, we arrive at what we have here, 1 times 10 to the power minus 10 meter. Now, if in an exam condition you don't see this value, doesn't mean you are wrong. But look at this, 10 to the power minus 10 meter is the same thing as 1 Armstrong. So in place of writing, instead of writing 10 to the power minus 10, if you see something like this, it's still correct. So the first option there is the correct option. Let's look at the second one that says, which one of the following parameters of the emitted X-ray increases when the potential difference between the electrodes of the X-ray tube is increased? The question is asking which parameter will increase when potential difference in the X-ray tube is increasing. And the first option is the intensity. Is it the intensity? A. Is it the frequency? Is it the wavelength? Or is it the speed? Okay, so there is an expression that will help us to attempt this. We know E equals to EV, E equals to HF. But this one comes with potential difference, EV equals to HF. So you can now see that potential difference, I wrote it in blue, is directly proportional to F, meaning when it is increased, F is also increased. When it is decreasing, F is also decreasing. And E and H are constants. So the correct option is the frequency. So take note of that. You can go through the question the second time, but let me proceed because of time. This one says the energy required to excite an hydrogen atom from n equals to 1 to n equals to 2 energy state is 10.2 electron volts. What is the wavelength of the radiation emitted by the atom when it goes back to the ground state? Also, the question is saying we should find the wavelength. What is the wavelength if the energy is 10.2 electron volts? In most cases, the constants are always given, but in a situation where the constant is not given, you should know what to do. Let's pick an expression. Recall that the change in E, change in energy equals to HF, and F is the same thing as C over lambda. The frequency is the same thing as C over lambda. So if we say change in E equals to H C over lambda, we are at the right position. Why? Because the question says we should find a wavelength. So the first expression came with frequency and is not suitable to solve this problem. So let's use this, and then we make the wavelength the subject. When we do that, we have wavelength equals to Hc over change in E, and the change in E is given as 10.2 electron volts, of which of course we know that H is a constant and C is a constant. Okay, so this is what we have listed them below. Then when you substitute the following in place of E, we have EV. EV, the energy is replaced. The change in E, we have EV. Okay, so here we have H, 6.6 times 10 to the power minus 34, C, and then the energy is given in electron volt. You are now going to use 10.2 EV. So we are going to multiply. I'm coming. Look at this. This is where I'm going. This is a constant, which is this value. So we are going to substitute 1.6 times 10 to the power minus 19 volts into that expression and multiply with 10.2. This is what I mean. When you do that, you will get okay. So this is how it looks like. In place of h, we put 6.6 times 10 to the power minus 34. In place of c, 3.0 times 10 to the power 8. In place of the value e, change in e, which is 10.2 eV, we have 10.2 times the value of the charge, which is 1.6 times 10 to the power minus 19. When you simplify this, you arrive at this. Okay, so looking at this, the answer is correct. But maybe in an exam condition, you look at it, you don't see your answer. It might be in the form of nanometer, which is still correct. It might be in the form of Armstrong, which is still correct. This is what I did. If I move this decimal point 2 places, 1, 2, I will have to power minus 2. Minus 2 minus 7 will give me minus 9. So this would be the new position of the decimal point. And remember, 10 to the power 9 is the same thing as nano. Okay, so we now have 122 nanometer. That's what I mean. If I go ahead and move the decimal point that was here one place, I will now have, this would be let's say, let me not do it here. Let me not do it here. At this point, if I move this decimal point that is here one place again, I will now have 0 here. And of course, this minus 1 minus 2, call this minus 3. Okay, so this becomes, let me just take it back. I move it 1, 2, initially was 2, 3. I will now have 1, 2, 2, this to the power minus 3. So minus 3 minus 7 will give me minus 10. So that's how we came across this. So it will be this, and the index becomes minus 10. 10 to the power minus 10 is 1 Armstrong. So we write it this way. So now look at it. The answer has changed from 10 to the power 1.22 times 10 to the power minus 7 meters to 122 nanometer or 1220 Armstrong. So if you see any of this, it's just for you to play with your indices. Doesn't mean that what you were doing was not correct. This one says, what is the maximum frequency of X-ray emitted from an X-ray tube operating at 50 kilovolts? What is the maximum frequency of X-ray emitted from an X-ray tube operating at 50 kilovolts? So we are to find the maximum frequency. You can pick an expression and then check an expression that is suitable. Maximum frequency is suggested E equals to EV equals to HF. So I will use HF because I've seen frequency as well. So we now say EV equals to HF. Okay. Making F the subject, we have F equals to EV over H. Why did I choose this? This expression you're seeing here, looking at this, the charge. Then what did they give us here? Potential difference 50 kilovolts. So this one will go here, and the constant, the value of the Planck constant. That's why I had to choose this very expression, because that one is complete. Now making F the subject, I will be using this when I substitute the value into that expression. I will get this. Remember, the value for the potential difference is not just 50 kilo. It's a language. Kilo means 1000. So we are going to change this kilo here to 1000, or we call it 10 to power 3. So you're going to do that by multiplying that 50 by 10 to power 3 in that very expression, and whatever it gives you is the correct option. F equals to 1.2 times 10 to the power 19 per second or hertz. So the unit of frequency is per second or hertz. Anyone you write is correct. Let's look at this. An X-ray tube produces a continuous spectrum of radiation with its shortest wavelength end at 0.66 angstrom. What is the maximum energy of the photon of this radiation? This very question says take Planck constant is given. If you will be in a situation whereby the Planck constant is not given, you should always recall it with the unit as well. But in this case, it is given. Okay, so solution, what did they say we should find? They say, what is the maximum energy? We have to find the maximum energy. Okay, H is given. The minimum wavelength is given, C is given, and E. So which expression are we going to use from the lots? I gave a summary of the expression. Also take note, before I continue, take note that this value here, you're seeing Armstrong here, is the same thing as 10 to the power minus 10 meters. So you are going to convert that exactly. Let's go on. Recall this. Change in E equals to Hc over lambda. We are going to substitute the above quantities into the expression. Then we convert 0.66 as well. When you do that, you will get this value. I would like you to try that and see whether your answer would be the same as what I have here. This one says a continuous X-ray spectrum is produced due to acceleration of electrons towards the nuclei of the target atom, retardation of energetic electrons when they approach the nuclei of the target atom, fall of the electrons of the target atom from higher energy level to lower energy levels. D. Knocking out of electrons from the target atom by the fast-moving incident electrons. I take it again. A continuous X-ray spectrum is produced due to, because of what? When there is retardation, the slowing down of energetic electrons when they approach the nuclei of the target atom. As the electrons approach the target, they slow down and they begin to emit X-ray photon. The correct option is B. In an X-ray tube, electrons accelerated through a very high potential difference strike a metal target. If the potential difference is increased, the speed of the emitted X-ray does what? What happens to the speed of X-ray? X-ray is an electromagnetic wave, and you know all electromagnetic waves travel at a certain speed. What speed is that? So this question might deceive us if we don't understand what we are doing very well. So if the potential difference is increased, what happens to the speed? A. Increase. B. Decrease. C. Remains unchanged. D. Is always equal to the speed of light in a vacuum. Of course, you know the speed of light in a vacuum is 3.0 times 10 to the power 8 meters per second. So we don't look at it whether it's increased or decreased, but the speed is always constant. D is a constant. That's why even in the problem we are solving, they are not giving us speed because we already know what the speed is. Okay. Look at the following study questions. This one is for you. You just solve it and think about it and check whether your option is included here. The question says if a hydrogen atom you ignore the at. Let me take it again. If the hydrogen atom emits a photon of wavelength, the recoil velocity of the atom of mass is, if a hydrogen atom emits a photon of wavelength lambda, the recoil velocity of the atom of mass is, what's the correct answer? This one, there is no option. It says the energy of a monochromatic X-ray of wavelength of 2 angstrom is roughly equal to. Just want you to pick a formula and then you know the constant, substitute, and let's see what would be your own answer. Convert from angstrom to meters. Then the last one here says what? The wavelength in A associated with a photon of energy E is, then a bracket, C is the where speed is the speed of light in A and H is the Planck constant. So the question is telling us, let me take it again, the wavelength in A associated with a photon of energy. But to find the wavelength in A associated with a photon of energy, and C is given and H is given, what would be the correct answer? What would be the wavelength if we have E, C, and H? You just pick the correct option. I think that's how far we can go. Thank you for watching. If you'd like to support our channel, please check the description below for more details. Thank you very much for watching. If you have subscribed, thank you. If you are yet to subscribe, please endeavor to click on the subscribe button. Do me a favor by liking the video and also sharing. Have a wonderful day. See you in our next class.